let's take a quick look at a short method that we can use to help us graph these quadratics. So we remember back graphing quadratics, our graph of a quadratic should be a parabola. So I've got an equation, y equals 5x squared minus x minus 6. And I'm going to go ahead and I'm going to factor that and I'm going to see what happens. But before I do, I look at my lead coefficient. I know it should open up. I don't know much else other than to try to plug in points and see where it goes from there. But I'm going to factor y equals, let's go 1x, 5x in my chart. Ways to get 6, 1 and 6 multiply to be 6, 2 and 3. Switch them both around, 3 and 2, 6 and 1. Signs are different. We want them to subtract to be 1. 30x, 1x, no. 15x, 2x, no. 10x, 3x, no. 5x, 6x, that's a yes. So up here, my first, I've got x, I've got 5x. Bottom here for my last, I want 1x to connect with 6. And I want 5x to connect with 1. Bigger one is going to be negative. 6x is bigger. So the 6 is minus. 1 is plus. Okay, so I've just got a different form. This is what we would call factored form. Or some people like to call it x-intercept form. Like we talked about in the earlier video, what these two parts can tell us is they can actually tell us where our x-intercepts are on our graph. So I'm going to go ahead and make some more room. I'm going to get rid of this stuff down here. And I'm just going to do a real quick sketch of this graph. And, well, I know that my x-intercepts are when y is equal to 0. So if I've got 0 equals x plus 1, 5x minus 6, that means either this first factor has to be equal to 0, or my second factor has to be equal to 0. Okay, so those are my two possible x-intercepts. Actually, they are my two x-intercepts, negative 1, comma 0, and 1 1/5, comma 0. So when it comes to graphing this, I can go ahead and I can say, and I forgot to load a graph on here, so I'm going to just draw a rough sketch here. And I'm going to say, well, I know that it should cross my x-axis at negative 1, comma 0, and it should also cross my x-axis at 1 1/5. I know it opens up. I also know that a quadratic, a parabola, has some symmetry. So my vertex should be halfway between these 2 points, somewhere in here. Well, how far is it between 1 1/5 and negative 1? So I'm going to take 1 point, my right point, and I'm going to subtract my left point. And I'm going to divide that by 2, because that'll give me halfway in between those 2 points. So it looks like I'm going to change that back to 6/5 plus 5/5 over 2. Well, that's 11/5 divided by 2, or 11/5 times 1/2 is 11/10. Or I could rewrite this as 1 1/10. Now that's not 1 1/10 on my graph, it's 1 1/10 away from each of my points. So if I go from my left side, I'd go to the right 1 1/10 over, right about in here somewhere. 1 would take me to 1/5, and then 1/10 would take me to right here, this 1/10. So my vertex has to be somewhere on this vertical line. So my vertex has to have a value of 1 1/10 to the right of negative 1, which would be 1/10. I could take this back in, plug it back into my original equation. That'll tell me exactly where my vertex is. Let's do that. So I've got 5x squared minus x minus 6. or negative 6 and 1/20th. So I know my vertex has to be at 1/10, comma, negative 6 and 1/20. 1, 2, 3, 4, 5, negative 5. Negative 6, 1/10, comma, negative, I got an extra mark in there, 1/10, comma, negative 6 and 1/20th. There's my vertex from there. I know that it's going to connect up through these x-intercepts. And I've got a rough sketch of my graph.